Okay, so looking at the structure of the atom and the periodic table and chemical formulae. So we're doing a bit of a recap. So we're looking at chapter 22 and 23 in the Nature of Science books. Okay, so these are the slides that we used in class. So in class, we looked at our learning intentions. Now, what we're planning on learning in this video is really just recapping on what we've learned in class, and then highlighting what an isotope is, and going over with a few examples how we're going to see how chemical formulae come together. So how many of one element bond with how many of another when we are looking at ionic bonds. Okay, so just to recap on a few things that we looked at in this chapter. So we said an atom is the smallest part of an element, and an element is a substance that can't be broken down into simpler substances by chemical means. Okay, so when we look through our slides, some things that jump out to us are the Bohr model. So we looked at a Bohr model and how we can draw an atom with using the Bohr model. And the other model that we sometimes used was the dots and crosses model. Okay, so in our Bohr model or our dots and crosses model, we can see these highlighted subatomic particles. So our subatomic particles, what were they? So our subatomic particles were our particles within the atom. So the electrons, and then within the nucleus we had our protons and neutrons. And we said the electrons which are outside and they're orbiting around the atom are -1. They're our negative charge. And then we have this nucleus in the center of the atom that has our neutrons and our protons. And our protons had a +1 charge. They were our positive charge. So because our electrons have a -1 charge and our protons have a +1 charge, most of our atoms were stable when they had a equal amount of electrons and protons in the nucleus. So usually our amount of protons tells us the amount of electrons we have because we have the same amount of electrons as protons. And we looked at how we can find this number of protons and neutrons and electrons using the mass number and the atomic number from the periodic table. Okay, so this is all stuff, when I asked you guys what would you like to revise, this is all stuff that you felt, okay, you're relatively familiar with, you don't really need to revise, or you don't want me to go through it with you as much, even if it means that you need to give it some of your own time in revision. But one of the things that you did ask me to highlight again was isotopes. So some periodic tables have the mass number given as a decimal number. And what does that mean? So we don't have, like, let's say 3.6 electrons. Okay, we don't have a 0.6 amount of electrons. So where is that number? Where is that 0.6 coming from? And it's when we start to kind of question things like that we see, okay, well, maybe one type of this element has 3. So maybe one of these atoms has let's say 3 neutrons in the nucleus, and some have 4 neutrons in the nucleus. And for that reason, it's saying 3.6 because it's somewhere, sometimes it has 3, sometimes it has 4. So it's kind of trying to figure out it's somewhere in the middle. And that's where we start to look at isotopes. So isotopes are atoms of the same element that have different number of neutrons in the nucleus. Okay, so that is all we need to learn for isotopes. So maybe let's take this down. So let's have a look at our definition of isotopes. So we can just learn a definition for isotopes. Okay, so we know what they are. So we looked at an example like carbon and said carbon 12 and carbon 14 are two isotopes that we know of. Okay, so isotopes. Okay, so what are they? So isotopes are atoms of the same element. Okay, so they're of the same element. So they, like for carbon 12 and carbon 14, they're both carbon elements. So they're atoms of the same element. Okay, so they're atoms of the same element. And they have different numbers of neutrons in the nucleus. Okay, so if you want to take this down in my words, you can, or you can take it down in your own words. Okay, either or is perfect. So they have a different number of neutrons in the nucleus. Okay, so we're not going to have a decimal point number of neutrons in the nucleus. So when there's a decimal point on the periodic table, what that's telling us is, well, it's kind of saying like if there's way more carbon 12s, let's say. Okay, let me finish writing down this definition before I go on my rant. In the nucleus. Okay, so if we look at carbon, okay, so we have carbon 12 and we have carbon 14. Okay, now in the periodic table, okay, if we look at the periodic table for carbon, let me just find it here. It comes up, okay, well, it's actually nicely rounded in that periodic table, but it would come up as, so like a square like this, and it would say C, and here it would have 12.01. Okay, so what would that 12.01 mean? Okay, so usually, it means that, okay, again, we're not going to have 0.1 neutrons in the nucleus, but what can we decide? Why is it so much closer to 12 than it is to 14? So usually, what the reason for this is that usually when we come across carbon, it's carbon 12. So because there's so much more carbon 12s, we're not just finding the average between 12 and 14, but what we're finding the average of is something like carbon 12, carbon 12, carbon 12, carbon 12, maybe carbon 14, then another carbon 12, then another carbon 12, and there's way more carbon 12s. So when we go to get the average of these, it's not just an average of 13, it's an average that's much closer to 12. Okay, so when we have an isotope, what we do is we just round this number to the nearest whole number. But in saying that, we do need to learn what an isotope is. Okay, so there's one definition of an isotope. So you can take this one down or write it out in your own words. Okay? So we were looking at the structure of an atom. And here we are with carbon 12 and carbon 14. Okay, so we can see here they both have a different nuclear number because they have a different amount of neutrons in the nucleus. Okay, so 6 neutrons here and 8 neutrons here. Okay, so we looked at drawing a Bohr model. You guys were happy with how you drew Bohr models. And now we are looking at, so isotopes. Again, here you can see the amount of neutrons in the nucleus is 8 versus 6 for carbon 12. Okay, so same number of protons, different number of neutrons. Okay, isotopes are atoms with the same number of protons and different number of neutrons. Okay, so it matters that they have the same number of protons because remember, when we're given a element, when we're saying the same number of protons, what that means is if I gave you some element, and I said, okay, there is 4 protons. So that means that there is 4 electrons. You would be able to tell me what element that is by looking at the periodic table and saying which element has 2 electrons in its outer shell, so it's in group 2, and it has two shells, so it's in the second period. So this atom is from the second period of my periodic table, and it has 2 electrons in the outer shell. It has a total of 4 electrons. It's beryllium. Okay, so this is beryllium. And I know this because it has 4 electrons, so 4 protons. Okay, so if beryllium had a isotope, then it would still have the same number of electrons and protons, but it's the neutrons that are changing. Okay, so that is another way we can talk about isotopes, that they have the same number of protons but a different number of neutrons. Okay, so whichever one you prefer to learn is perfect. So here is beryllium. So see here, both berylliums have 4 protons. Okay, so they have 4 electrons, but they have a different amount of neutrons. Okay, so moving on, we are going to start looking at we want to look at the ratios when different elements react with each other. Okay, so when we are looking at this, we need to look at, okay, well, how do different elements react? So remember what we said about a group. So a group is a column of elements in the periodic table that have similar properties. And one of the properties in these groups was how many electrons. So I am skipping through some stuff because you guys didn't ask me to go through it. But what you did ask me to go through was why they kind of come up with the ratios that they come up with. So remember that we're looking at the first 20 elements in the periodic table following this octet rule. So they want a full outer shell. Okay, so in my periodic table here, okay, this group 1 have 1 electron in their outer shell. So they are just very, very close to having a full outer shell by giving away 1 electron. Okay, so I have something like lithium, and it wants to give away 1 electron. So this wants to give away 1 electron. So it's going to try and find an atom or an element that wants to take 1 electron. So it wants to look at these group 7 elements here that could take 1 electron. Okay, so a common reaction we see between a group 1 and a group 7 element would be NaCl. Okay, so Na wants to lose 1 electron. So our Na, so my two elements here are Na and Cl. So what do we know about Na? It's in group 1. Okay, so if they say what ratio do Na and Cl bond in, well, I need to look at Na is in group 1. Cl is in group 7. Okay, so Na wants to lose 1 electron because it's in group 1. It has 1 electron in the outer shell. So if it can lose that 1 electron, it means it has a full outer shell. Okay, so it wants to lose 1 electron. And Cl wants to gain 1 electron. Okay, so they are ready to do a straight swap. This wants to lose 1, this wants to gain 1. So they are going to pair up as NaCl. Okay, they are just going to pair up nice and easily as NaCl. So in other words, one of each. Okay, so one Na with one Cl. Okay, so we're going to have sodium chloride, which just has one sodium atom with one chlorine atom. Okay, let's have a look at a different one then. So what if I said something like Na again? So Na, and this time let's see how it's going to, let's see how it will pair with bromine. Okay, so you guys can try this one. Okay, how are they going to pair up together? So you can pause now and try that. So again, this one is group 1. So what does that mean? It wants to lose one electron. And this one, bromine, well, let's have a look at what group it is. So it's group 7 again. So group 7, which means it's going to react the exact same way as the Cl did with the Na. Okay, it wants to gain one, so they are going to match up in a nice 1-to-1 ratio. Okay, so their ratio, the ratio of Na to Br is going to be 1-to-1. So when they bond together, it's going to just be Na Br. Okay, now let's have a look at if I had something like okay, so aluminium, Al, and my bromine, so Br. Okay, so we said my bromine is in group 7. So we have group 7 here. So that means that wants to gain one electron. Okay, and now let's look for my aluminium. So it's here. So aluminium is in group 3. So aluminium is in group 3. So what does that tell us about aluminium? How many electrons does it need or want to get rid of? It wants to get rid of 3 electrons. Okay. So is aluminium going to be happy if bromine comes over and just takes 1 electron? Is aluminium going to be happy? If it just gets rid of 1 electron, it still has 2 in its outer shell. So it's going to just be like, no, I'm not doing that as a deal. Okay, I want to get rid of 3 electrons so that I can have a full outer shell as well. So instead of aluminium bonding just with 1 bromine, we actually are going to have 3 bromines come over to an aluminium and say, oh, we'll take 1 each. So if 3 bromines come over and take 1 aluminium each, then all those 3 bromines have full outer shells, and the aluminium now has gotten rid of the 3 electrons so that it has a full outer shell as well. So when these bond together, they are going to bond in the ratio. So for every Al, how many bromines do we need? We need 3. So they're going to bond in the ratio 1-to-3. Okay. Now remember how we write our chemical formulae. So we said something that we know, like H2O means 2 hydrogens. So 2 hydrogen atoms and 1 oxygen atom. Okay, because the oxygen doesn't have a number afterwards. So here, if I want to show that when these bond together, there's going to be 1 aluminium and 3 bromines, how am I going to do that? I'm going to say it's Al and then B or 3. So remember, the first letter of each element gets a capital and the rest are small case. So capital A, small case L, capital B, small case or, and then to show that there's going to be 3 bromines, I do a small 3 there. Okay, so let's have a look maybe at I'll get you guys to do a few now. Okay, so I'm going to get you guys to do a few. So I'm going to get you to do, let's see. So I'll get you to do aluminium. We've just done with bromine. So let's do, and chlorine. Okay, so these are the ones that you're going to do. We'll put numbers on them. So part 2, you'll do aluminium and nitrogen, so N. You can do, let's see. Okay, let's do barium, so Ba with some bromine. We can do, let's do an aluminium with oxygen. That'll be a nice one. Okay, we can do, like, I mean, we can literally do endless ones of these. I don't know why it's so difficult. It's like, it's as if I said, give me 6 random numbers. It's actually really hard to just come up with them. I don't know why. So for 4, let's do, okay, so let's just do calcium. And we'll put that with nitrogen. We'll do lithium with sulfur, and we can do another one. Let's do iron with phosphorus. Okay, now we can do this one together. We'll do the iron and phosphorus one together. But do still write it into your copies. Okay, so those are the ones that you guys are going to do out for me in today's work. Okay, so we'll do out the part 7. So we have iron and we have phosphorus. Okay, so let's have a look at our periodic table and try and find iron. Okay, so where is iron on this periodic table? Okay, so iron. Oh my god, why is this actually really hard for me to find? It should be here. Why can't I see it? I'm actually close to having to pause this video and trying to see it here. I'll try look for it on this one. Okay, I have no idea why I cannot see iron. Okay, anyway. Iron is in group 2, so it loses 2 electrons. Okay, now I don't know why I cannot find it here, but I know, I'll tell you now, iron loses 2 electrons. Okay, so iron, I don't know if you guys could see it, it loses 2 electrons. Okay. Whew, that was a nice waste of time. Phosphorus then. Okay, so if we try and find phosphorus, we will find that phosphorus gains 3 electrons. Okay, so phosphorus gains 3 electrons. Okay, so I will tell you how many each of these need. So iron loses 2, so -2, and phosphorus wants to gain 3. Okay, so just in case we can't find the other ones, lithium loses 1, sulfur gains 2, Ca, so calcium loses 2 electrons, and the nitrogen gains 3 electrons, so that's going to be quite similar to this one. And then we have aluminium, so it loses 3 electrons, and oxygen, so it wants to gain 2 electrons. Barium loses 2 electrons, and bromine gains 1 electron. Okay, so we can find these by looking at the periodic table. So Al, Cl, and N we'll be able to find it easily on our periodic table. No, we won't. Okay, so the one thing I will say to you is usually given a periodic table like this, you'll just be given, oh, there's aluminium there. Okay, so what was it that I was looking for? Anyway, usually in an exam, you'll just be given the elements up to 20 to use. Okay, so it will be one of these first 20, okay, up to 20 electrons in the outer shell. Okay, so things like aluminium, nitrogen, oxygen, lithium, all these, sodium, all of these ones are the ones that you'll be asked for, because you'll be able to see by what group they're in how many electrons they have in their outer shell. And once we know how many electrons they have in their outer shell, we know how many they want to lose or gain. Okay, so iron wants to lose 2, phosphorus wants to gain 3. So how are these ones going to match up? So this is kind of a difficult one. We can go through this as like a process of elimination. We can just try a few things out. So for example, if we had 2 irons, that means that they would want 4 electrons. Can it work if they want to lose 4 electrons and phosphorus only wants to gain 3? No, that can't work. Okay, could it work if we maybe got 3 irons and 1 phosphorus? So if we had 3 irons, that would mean we'd have 6 electrons we want to lose. So if we had 3 iron atoms, they'd want to lose 6 electrons altogether. And if we had 1 phosphorus atom, it would want to only gain 3 of those 6. So it wouldn't really work. But what if we had 3 iron atoms with 2 phosphorus atoms? Okay, if we joined them in the ratio 3 to 2, then what we'd see is 6 electrons would want to be lost from the iron, and 6 electrons would want to be gained from the phosphorus. So that's how these ones are going to come together. So we're going to have 3 irons and 2 phosphoruses. Okay, so when we write this formula, it's going to be Fe3P2. Okay, now I'll give you a little hint as to how we come up with these numbers and the ratios. Okay, we're always looking for the lowest common multiple, the lowest common denominator almost, of these two numbers. So here, so in an example like this where I have 1 and 2, my lowest common multiple of 1 and 2 is 2. Here my lowest common multiple of 2 and 3 was 6. So they multiplied to give me 6. Okay, here my lowest common multiple again is 6, 6, 2, and so on. Okay. So yeah, okay, so I am gonna leave it there, guys. Hopefully you will get through these ones okay now that we've done a few examples. Okay, so I'm gonna get you to do out these other ones, and when I see you guys in class then on Thursday, you can let me know how you got on with them. Okay, so I want everyone to do these out, and then I'm going to put up stuff to do with your CDA to go on to after this. Thanks, guys.